Welcome back to Tech Reviews, where engineering meets knowledge. In today's episode, we're exploring one of the most vital yet often overlooked parts of a steam turbine, the thrust bearing and the journal bearing. These two components may look small, but they play an enormous role in keeping a turbine stable, safe, and efficient. Without them, even the most advanced turbine would fail within seconds. So, let's break it all down: what a thrust bearing does, how it controls the turbine, how the journal bearing supports it, and why both are the true backbone of every rotating machine. Gear understanding the thrust bearing. Inside a steam turbine, the thrust bearing is the component that controls axial movement, the forward and backward motion of the rotor. When high-pressure steam enters the turbine and strikes the blades, it produces a strong axial force in one direction, usually pushing the rotor toward the generator end. To manage this force, turbines use a tilting pad type thrust bearing at the front side of the turbine, while a solid bearing or sometimes another tilting pad unit is positioned at the rear side. The front tilting pad bearing usually carries the main axial load, while the rear bearing simply stabilizes the shaft or takes up minor reverse thrusts. In some turbine designs, both sides are tilting pad types, but in most cases, the front bearing carries the greater share of the load, because that's where the steam pressure acts the most. As the rotor spins, the axial thrust from the steam flow is transmitted directly to the front thrust pads. These pads are slightly tiltable, allowing them to form a perfect wedge of oil film beneath the rotor collar. This thin film of oil is what actually carries the load, the metal surfaces never touch. The oil film supports the rotor, absorbs the axial load, and maintains a smooth, friction-free motion even at thousands of revolutions per minute. High voltage. How the thrust bearing controls the rotor. The tilting pad thrust bearing acts like an intelligent controller. Each pad automatically adjusts its tilt angle depending on the pressure and speed of the rotor, creating the ideal oil film thickness at every moment. When the turbine starts up, the rotor tends to move forward due to steam thrust. The thrust bearing counters that motion instantly, the oil pressure builds up, the pads tilt, and the rotor is pushed back into its correct axial position. It's a continuous balancing act, happening in milliseconds, that keeps the rotor perfectly aligned with the stationary blades inside the turbine casing. If this axial position is not maintained, the turbine's efficiency drops, the blades can rub against diaphragms, and vibrations can increase dramatically. So, the thrust bearing is not just a support, it's the axial positioning system of the turbine, ensuring precision, balance, and stability at all times. Front versus rear thrust bearings. In a typical setup, the front thrust bearing handles the main axial steam load, while the rear bearing provides reverse thrust control when the turbine slows down or shuts off. During normal operation, 90 to 95% of the total thrust is taken by the front tilting pad assembly. Because of this, the front bearing is often built with extra cooling and oil flow passages to manage the higher load and temperature. It's also made from high-grade Babbitt or nickel alloy, ensuring durability under continuous heavy pressure. The rear bearing, on the other hand, usually has a solid or flat pad design. Its job is mainly to keep the rotor steady if reverse thrust occurs, such as during sudden load changes or emergency shutdowns. Compass. Why the thrust bearing is so important. The thrust bearing is one of the most critical parts in the entire turbine system. If it fails, the rotor can shift axially, causing blade collisions, seal damage, or even complete mechanical breakdown. That's why thrust bearings are fitted with temperature sensors, axial displacement probes, and vibration monitors to detect any abnormal movement in real time. The bearing doesn't just resist force, it defines the operational geometry of the turbine. It ensures that the blades and nozzles maintain their design spacing and that the efficiency of the turbine remains at its peak. In short, the thrust bearing is the guardian of axial stability. Without it, no turbine can function safely. Gear understanding the journal bearing. Now that we've handled the axial movement, let's move to the second key component, the journal bearing. While the thrust bearing manages the forward and backward forces, the journal bearing controls radial loads, the up and down and side-to-side movement of the shaft. The turbine rotor is extremely heavy, sometimes weighing several tons, and spins at very high speed. The journal bearing supports this rotating weight, allowing the shaft to spin freely and steadily. It works using the same principle of hydrodynamic lubrication. A thin film of oil forms between the rotating shaft, called the journal, and the stationary bearing surface. As the shaft rotates, it drags the oil around, building up pressure that lifts the shaft and keeps it centered. So again, there's no metal contact, only the oil film carries the load, minimizing wear and vibration. High voltage. How the journal bearing stabilizes the turbine. The journal bearing is responsible for maintaining radial stability of the turbine.